Hello everyone, I'm sitting here with Giulia Boller. Thank you so much for taking the time.
Thank you, Leon.
Before we start, could you briefly introduce yourself in regards to how you found your way to architecture and engineering and how you found your first contacts with this current topic of engineering history that you do at the ETH?
Of course. First of all, my background is both in engineering and architecture. I studied both disciplines, and I started then working for Renzo Piano Building Workshop for a couple of years. And of course, also in that case, the topic of lightness that you discuss in this podcast is quite relevant, I would say, in the work. And after working there for some years, I decided to do a shift in my career, starting a PhD at ETH Zurich. I was accepted at the Institute of Technology in Architecture, at the chair of structural design of Professor Josef Schwarz, who basically had a research project on the work of Swiss engineer Heinz. Of course, I am Italian, so when we speak about history of engineering, the first protagonist that we think about is Luigi Nervi. I was pretty much fascinated also during my studies about reinforced concrete structures and the relation between architecture and engineering in the history. Something that I felt also during my studies that was not really a topic that was under the radar of architectural or traditional architectural historians, and it was not something that was taught usually in the schools. And whenever this possibility came to me, I decided immediately to start working on this topic. And I had the privilege of having a very good atmosphere and environment at ETH, where I could really dive into original archival materials of Heinz office. Heinz is one of the most well-known shell builders in the history of engineering. He was from Switzerland, from the canton of Bern, and basically the full archive was acquired by ETH Zurich after his death in 2009. So I spent basically a bit more than 4 years working on this archive, and especially I worked on the way he was actually working in his engineering practice in the office with the physical models that we will probably discuss afterwards. And for this reason, I stayed also in my academic career. Now I am a senior postdoctoral researcher and lecturer here at ETH between technology and history still. And I always try to combine these two topics, let's say the history of architecture with the history of engineering, trying to also find ways to make it relevant for today's contemporary practice.
Yeah. Wow, that's quite a lot of time that you spend on really looking into the archive. I wonder a bit how this works, but we'll come to that. If I say the word lightness, what is the first thing that you think of?
Lightness, of course, if we think about the history of engineering, let's say, lightness is something that links my memories or my reflections to the work of the people that made first lightweight structures well known in the world. So somehow we speak about mid-20th century most of the time. We speak about people that were mostly working with spatial structures that were trying to make also heavy materials somehow very light in terms of image, in terms of the way the forces were brought together to create equilibrium, and in terms of the overall references that inspired this protagonist. Of course, one of the first references is the German architect, structural designer, and professor Frei Otto. But then there are many others. Also, Robert Ricolais could be also considering these lines of thought with his tensegrity structures. And even Heinz, even if he worked with reinforced concrete shell structures, to a certain extent, we can consider it part of this lightness.
Yeah. Of course, it is still concrete, and there is a heaviness to it. I also read in your book that recently was published, or the GTA book on Heinz Isler. Very nice book. It's called Heinz Isler Build Experiments, Entrepreneurial Networks. And obviously it's a huge collaboration of many people, but it is quite a deep research into the way Heinz Isler worked, and we're definitely going to talk about that. I'm going to talk now a bit about this first definition of lightness, the lack of weight, which you already put a bit into terms of how something visually can seem, but maybe the numbers don't add up to that impression. But in general, we could say that, like, in the last century, our buildings have become much heavier. Wood has been replaced by concrete and steel. But inside of this century, for people who are fascinated by lightweight structures, there was this golden era in the mid-century where maybe also labor cost was lower than the material cost, and therefore there was more space for experimenting with intricate forms. While nowadays it seems very much the opposite. And although we have this obvious resource finite situation, we know that we don't have endless resources. Our built environment doesn't reflect that at all, and everything is fairly heavy, and forms are fairly simple.
Yeah, and this is, I believe, it's quite kind of a key aspect of it that we can really learn from the past. Because in my opinion, when we speak about lightness in the structural design, or in the relationship between engineering and architecture, it's not only about heaviness in terms of kilogram per cubic meter, but it's really about how much material you employ and where you place it somehow. And in this sense, I think that the people that developed processes or design processes that helped place the material where it was actually needed and try to make structures that were as thin as possible, where it was not necessary to have this big amount of material. This is something that can still be of inspiration for today. So somehow what I try always to say with the students when we have this type of discussions is that somehow, as you said, maybe the context is different. Back then they had to reduce the material because the material was very expensive. And the labor cost was quite cheap, let's say. Nowadays, this is the opposite. But somehow, if we think about the future of our discipline, this is something that we can take into account. We don't speak anymore about the material efficiency in terms of the cost of the material, but we still speak about material efficiency because of the limitation of the resources that we have. So in this sense, we can also consider concrete structure as lightweight structures. If we consider really the weight of these structures. And in this sense, of course, when we speak about form finding, so approaches that help define specific shapes or forms given specific boundary conditions and specific load cases, then we can really derive great examples and have better ways of designing that can make sense of wherever we place the materials.
Yeah, very well said. My next question would be, what made it possible for these people like Frei Otto, Isla, also Félix, Candela in Mexico to explore these new shapes? We already talked about the material and labor cost. What other things happened that made it possible for these pioneers to use less material?
I think there are different factors, as you said. Definitely the economic factor was very important. And of course, there were contexts like Mexico or Italy, where the labor cost was even cheaper than other contexts like Switzerland, for example. And for this reason, Félix, Candela, as you mentioned, or Pier Luigi Nervi, or others, had to develop also creative solutions to develop long-spanning structures to overcome the difficulties that they had in their countries. But at the same time, I think it was also a cultural context that had a big influence. It was a moment in engineering where all of a sudden many things started to become possible, something that was never possible before. Back then, whenever somebody wanted to build a long-spanning structures, it was mostly done through a dome with masonry, or it was mostly done with geometrical shapes that could be easily controlled with mathematical equations, very simple mathematical equations. And this is also somehow the approach that Félix, Candela, for example, started to adopt and continued to adopt in his career. He is mostly famous for hyperbolic paraboloid shapes, which are shapes that basically can be defined very simply with mathematical or analytical approaches to control the structural behavior. At the same time, it was really the moment when these new materials, and I speak about mainly reinforced concrete, but also steel, in terms of steel cables, were really pushed by both research institutions, so research that was developed with these materials, and at the same time with the companies that had developed such materials and the technologies that were linked to that. I think about the pre-stressing technology that was first applied between the 40s, basically in the 40s and the early 50s for the first time. And this cultural moment made it all of a sudden possible big spaces to be visible and to make them accessible in an easier way, let's say. And this is also true for, this is also the reason why some specific architectural programs started to become more and more present. Industrial buildings without column in between started to become part of it. Big hangars, I think about the Fressinet structures or the Nervi hangars in Orvieto, and sports facilities, churches. These are all architectural programs that started to become more and more present in the everyday environment, let's say. So it was really a moment when it was not a specific geographical focus, it was really something that happened all over the world and started to become part of also the architectural language of architects. Because, of course, this is one of the moments when engineering had an influence also on the architectural history, let's say.
So also a golden age for engineers in a way, because
yeah,
of that.
It was the first time when basically also architectural historians started to speak about the engineers. Sigrid Gideon published a book and included the work of Robert Maillard, for example. Something that was before that it was really not really the case. Since the establishment of the polytechnic schools. So it was really a change of paradigm when engineering had also an influence on everyday communities and not only on bridge design, let's say. And the fact that then some specific protagonists started to work in different locations with similar techniques, this is something that still is quite intriguing for me. Because between last year and this year, we celebrate the 100th anniversary of Frei Otto last year. This year is Heinz 100th anniversary, and Sergio Musmeci, an Italian engineer that also worked with physical models and form finding. And of course, Musmeci didn't know Heinz Isler. And Isler and Frei Otto had some contacts, but they were not really friends, let's say. But in different moments, they all started to work on similar topics, and this is also.
What do you think is the role of biological matter in this movement, or biology, the inspiration from natural structures?
This is something that that also started to rise in those years, even though a bit before, or somehow specific publications started to be also in vogue among the engineers, especially the book by Darcy Thompson, that was published much before Frei Otto and Isler started to work on these topics, but had a big influence on them in the way they were conceiving structures. I think that on the one hand, it's somehow an alignment of different fields that started to work all in these directions. On the one hand, biology started really to study these processes, and this is something that especially Frei Otto was pretty much fascinated about. He had also a biologist in his research group, so he was really a big fan of these developments. But on the other hand, Heinz Isler had a different view on this aspect. He used mainly biological processes as a formal inspiration, but he never really tried to reproduce these processes as Frei Otto instead tried to do in his experiments. And Sergio Musmeci had a similar studies, but more from the mathematical perspective, to try to understand through equations how to control these processes. And I think that also the developments on the discipline in terms of biological sciences, but also in terms of mathematical description of these shapes was something that started to fascinate also engineers. Maybe one of the very first that I was also quite intrigued when I started entering this field of research was basically a follow-up book of the graphic static, so the manual of graphic statics that had been published here at ETH in the 19th century by Carl Kuhlmann. And there is a second, a follow-up handbook by Ritter. He is successful as professor of structural engineering, where he published the applications of graphic statics method to understand specific typologies, structural typologies. Of course, we have a lot of railway bridges. It's the moment in the 19th century of the bridge development and so on. But one of these applications is the understanding of the bone structures, the inside structure of bones, based on graphical methods that were initially developed for structural design. So this link between biology and structures is something that started in the 19th century with the new disciplines, but is something that still fascinated a lot people in the mid-20th century, and maybe still today if we think of the work of some other scholars in this disciplines.
Yeah, I think one aspect of biology is also that material is expensive in natural structures, or so it seems. Like these intricate forms are also maybe can be seen as a correlation to this idea of cheap labor, or we can do all these shapes, but we don't. We're very the material is scarce. So in a way, I think that's an interesting way of connecting.
It's a way to optimize the material in a natural way. So
what are some of your favorite structures?
In general, you mean?
Yeah.
Or, it's of course. I would say one of the most elegant structures that I found when I was working on my doctoral thesis on Heinz is definitely the Daitingen motorway station, which is probably one of the most famous building by Heinz. But somehow it's quite intriguing because it's very simple. It's probably the simplest form that you can consider. Is a triangular, it's a concrete shell with a triangular plan that is then symmetrically mirrored. But it's very elegant because it doesn't have any facade. It's simply sitting with two supports on the roof of a small box in the middle and one support on the ground. So it's really something that if we think about lightness, I feel that this has the potential of being considered a lightweight structure, even though it is a concrete building, let's say. And so this is definitely one of my favorite. Another structure that is that was somehow important in my understanding of the discipline and in my educational training were definitely the structures of Nervi in Rome. Maybe not so much the Palazzetto, the one that is mostly famous, but the l'Anificio Gatti still in Rome. I think that is quite interesting in terms of the way it was constructed. It is a slab, so it's not a spatial structure in the sense that it's not a shell, let's say. It's a slab, but this slab is really reduced at its minimum due to the accurate control of the forces with the shape itself. Another one is a industrial building close to between Bern and Zurich. It's a concrete factory by Heinz, one Swiss engineer that is maybe not so well known outside of Switzerland, but is very well known in Switzerland. He was one of the first ones that started really the collaboration with the architects. In this case, it's more an architectural masterpiece than an engineering work. So somehow this relation between engineering and architecture, or if we just speak about design, I think that this is something that is really striving, let's say.
I think I saw it when I went to the exhibition at ETH 2 weeks ago.
Yes, exactly.
It's almost like it has this dress in the bottom opening up, and then this super light truss coming off, right?
Yeah, and it's very interesting from several perspectives. Is the Kieswerk Gunzgen close to Olten, and somehow it's very massive at the bottom. And then it's very lightweight on the top part, where there is a simple skeleton structure in concrete, and then everything is clad with a modular facade that was produced in series, casting one piece above each other. And this possibility to be very flexible, also according to the technologies that were allocated inside, due to the change of technologies, or the need to change the technologies over time, with the possibility to dismantle the facade, change the technologies, and replace that again. This is something that was really interesting in the work and in the research that we have done recently on Hostor's work.
All right, thanks. I have more buildings to visit now. All right, let's talk a bit about lightness, about the light aspect of it. There might be a correlation between like the physical lightness of structures and their ability to like capture light and create special light atmospheres. Obviously, this is especially true for membrane structures because they give this very special translucent quality to the space. But I would say in general also these, when the structure is unusual or unusual shapes, that can make for special light conditions. What do you think is the role of light in this pioneering movement of the mid-century with lightweight structures?
I think that somehow lightness is really linked to this aspect of the visibility, or even better, the transparency of it. Somehow, of course, I remember when I was working at Renzo Piano Building Workshop, that one of the aspects of lightness that were always mentioned when they were designing projects, it was about the possibility to make a transparent space, which doesn't mean that transparent it has glass and you can see through, but it's more linked to transparencies as a meaning of being able to see the different layers of the space. So you don't just see the first space that you enter in a building, but you see the stratification of these spaces and how you can go through the building. And this is something that the office of Renzo Piano Building Workshop is very good at, especially in the public spaces. And this is something that we can definitely see it when we speak about light structures in this sense. I recall when I was working a bit on the Olympic Stadium project, for example, one of the key aspects of these membrane structures, cable net structures, was the possibility to make the roof transparent, but at the same time opaque, in the sense to be able to capture light, but also not to mirror the light for the televisions, because at that time it was it was a public event, and the Olympic Games were the first time that basically massive television programs were showing the games to the bigger public, let's say. And so for this reason, they had to develop a specific material and a specific patent to be able to reach this light aspect with specific conditions that they were required by the mass media, let's say.
This is the San Nicola Stadium, or what?
The Olympic Stadium in Munich, the one that was designed by
Yeah, okay. Now I understand where we're at. I thought we were still talking about Renzo Piano, but okay, yeah.
No.
The plexiglass.
The plexiglass panels that had been developed had to be patented, let's say, because of that. It's really a specific. Now, in the case of Renzo Piano, or at least what I recall, is that the transparency of these spaces that I was mentioning, it's particularly present in the Harvard Museum that they built and designed, where a specific photograph has been published multiple times, where you can see this transparency that is going through the different spaces. And I think that this is an aspect that we can really see in the history of engineering as well. It's kind of more tricky to achieve if you use concrete, of course, specifically when you do long-spanning structures. And in particular, Heinz was pretty well known for his hanging membrane methods that helped him to find perfect shell shapes under compression forces if reversed of 180 degrees. And in this case, one of the major issues was the fact that right in the middle of these shells, you don't have natural light anymore. So either you use artificial light that has a completely different, atmosphere it creates, or you achieve natural light by opening the shell in specific points with skylights. And this is something that, of course, how you cut the shell to open a skylight. This is something that was quite important in his career, and it was also the very moment when Isler's office started to develop plastic materials to be able to achieve this lightness, let's say, by removing some concrete and opening it to let the natural light come in. So this is an aspect that is really linked to this discussion.
Yeah, it's interesting because he did some structures from mostly like glass fiber panels, right?
Yeah.
Which also have their own way of behaving as a shell, these skylights. So it's like a little shell on top of a shell. And they do share to a certain extent the light qualities of a membrane, because they're normally not transparent, but they have this translucency, right?
Yeah, somehow on the one hand you have this idea of a natural environment, let's say, or linked to the biological world that we were discussing before, because of course specifically these plastic materials, fiber reinforced polyester materials, age quite easily. So they become, they start as almost transparent or little white, let's say, but then over the years they become yellow. And if you go to visit most of the buildings of Isler nowadays, you see them that are the ones that are not that have not been restored. They are towards yellow or even brown, so they change completely the appearance of that. But it's true because also the procedure to develop these skylights was achieved by hanging a membrane and then laying out the fibers by hand. So this is also a process that was implying very simple materials and everyday tools that were available quite easily with Isler's collaborators. And it was the first time ever that a little shell with such newly developed materials, we speak about the mid of the 50s, so fiber reinforced polyester was really at the beginning, had been adopted for producing a skylight with an 8-meter diameter.
Wow.
So, the legend says that after Isler office had produced these skylights, basically he sold the license of producing them to a company in Switzerland, and with the money he was able then to open his own engineering office. So this is a bit of the story that has been always told by him.
Yeah, it's also a great idea that because of his model methods, he was able to even come up with this product in a way. It's almost based on this.
Yeah, it's exactly the same as we were saying with the form finding technique of the hanging membrane. It was a similar technique through which he developed his sky.
All right. What spaces do you remember where the daylight played an essential role in how the space made you feel? You can take a second.
This is a difficult question. But do you mean in the case of Heinz Isler or in general?
In general.
In general. A recent structure that I visited where I was really caught by the light that was coming in. It's a structure, it's a market hall in Algeciras in Spain by Eduardo Torroja. From the, if I'm not wrong, from the early 30s or something like that. It's a concrete shell, also in this case, but it has this skylight in the top that is really able to bring in a lot of light in a very gentle way, and it gives somehow a special touch to the structure. We are in Spain, but you feel the influence of Islamic architecture somehow in the way the light comes in. So this is kind of peculiar, I will say.
Sounds great.
As a structure. And this is the first thing that at the moment comes to my mind when I think about a specific light condition that caught my eye.
Yeah. All right. I'm thinking of because I lived in southern Spain for half a year, and we had this Arabic balcony, or at least it was. It used to be when the city of Granada was partly, it was like split into Jewish, Christian, and Arabic quarters. And in the Arabic quarters, you would have these wooden balconies that are like attached to the facade, and they have this like many little shutters of light that you can open and close, and you can decide how much you let in, and you can look in the outside of it.
Yeah.
I'm just thinking of that when you said these qualities.
No. And it's a very simple design, I would say, but it's really powerful. So this is something that really caught and somehow gives us a sense of quiet atmosphere in the middle of the chaos of a market. Of a public market.
Torroja was also quite early in building concrete shells, no?
Yeah, he's considered one of the early pioneers, and he was specifically also one of the early pioneers of using physical models to control the structural behavior of his buildings. Even though he always used geometric shapes somehow, so it was not so hard, but since it was really the very early years of concrete, this is something that was somehow necessary to control. So he was one of the first one who established a model testing laboratory in Madrid, and based on that, also ETH Zurich decided then to open its own model testing laboratory in the civil engineering department, where Israel also worked. So there is somehow a connection. And of course, when I was in south of Spain for holidays, for other reasons, let's say, I saw this, on the signpost that the city of Algeciras was very close, and of course my memory came to this market hall that I had seen only 2 books until then.
That's the beauty of being an engineering historian, that you sometimes are just close by to one of these structures and you get to see it.
Yeah.
I know that feeling.
As an Italian, I also learned Switzerland through the structures of Islam somehow, since you build so many. Whenever I go, I see specific villages, and I remember which types of structures should be there. So
it's like you're wearing glasses that are focused on this topic no matter where you go, right?
Yeah.
All right, let's talk about the feeling of lightness, which is very much also, I feel like, connected to this era of lightweight engineering. That there was this almost like they're hunting this feeling that on one hand, this physical lightness, right? When you see photos of people standing on the aviary that Frei Otto made, and they're standing on this thin mesh and it's barely anything, and you get this feeling of physical lightness. Or there's obviously more aspects to it, that you can have these moments of emotional or mental lightness when you just manage to do something big, or but it's often short, small moments that people remember. So what are moments of lightness for you?
It's somehow, I totally agree with you that somehow in those periods, or at least when you speak about the feeling of lightness, I immediately have in mind not the image of Frei Otto collaborators on the cable nets, but the images of Félix Candela's builders on some of his prototypes of the umbrella-shaped hyperbolic paraboloids, where you have this little column in the middle and then this huge span that is going both on the left and on the right side. And I don't know how many people are standing on that. So somehow you have on the one hand the assurance that this structure is very stable, because these people witness the fact that they can, many people can stand safely on top of that, but at the same time you have also this feeling of movement. So I think the feeling of lightness is pretty much linked to the feeling of stability and safety in structures. Somehow engineers are used to make stable structures, because the movement is not really seen as a positive effect whenever you design. But quite often, whenever you design something that can also move or has this feeling of movement, somehow you have finally this feeling of lightness as well. Maybe this is more visible when you design a bridge, a footbridge, or a small footbridge, where people, especially with hanging bridges, people can just jump on it, and you really feel this. You have this feeling. In structures is a bit more tricky or a bit more difficult, but I think that this is something that you can really appreciate. Maybe something that with Heinz is not so visible, I would say. But maybe something that other offices or other protagonists made it more perceivable. Let's say, like the Stadttheater in Basel of Heinz is a shell structure in reinforced concrete, but is a hanging membrane in the end. It's very massive, but this feeling of lightness is something that you can see from the interior architectural space, where all of a sudden the roof is going on top, and you somehow you see it disappear towards its height. And so I think it's pretty much linked also with the architectural perception of the space that you have close to it.
I think it's also visualizing forces in a way, you know. This shape is like visualizing gravity in a way when something is hanging, right? Or also this impossibility, this feeling that how can this, like with Candela, how can this little column hold all of these people? It's like this, you feel like you're at the limit of something in a way.
Yeah, exactly. No, I think this is something that was really important in that period. And of course, we were speaking about it at the very beginning. This idea of being all of a sudden capable of achieving specific spans, specific heights. And probably nowadays we are a bit over with this period. Nowadays, with a combination of technologies and softwares, is more or less possible everything, but it's more a question of what makes sense nowadays. And so maybe this type of prototypes are not so heroic in the image that they can show, but still have this power of having an image that is representing somehow the full concept.
I think it would be great to go back a bit and go back to structures that also show a bit more the liveliness and movement of our natural history in a way. I think I think we're very far from that. And of course I sometimes pity that, but I read But I think that, if we combine the challenges that we have nowadays with the material scarcity of the material resources, and we combine them, having again courage in defining these shapes or these movements, as you were saying, I think it will be quite an interesting moment for the architects and engineers. Maybe we don't need anymore these such big spans or these big structures, but maybe the same approaches can be used for smaller spans. Yeah, in a way you can already see some examples of this popping up again. I'm interested in this regard, how we can also make this scarcity a reality, even though it might not be one yet, you know? Like maybe concrete is still super cheap, but how can we make up conditions where you respect the material a bit more in its quantity? But that's a whole
and also at the same time is again the question, maybe we can still do something with concrete that makes sense as the block research group is developing, for example. And so it's kind of a difficult situation, but probably we'll go to another topic in this sense.
Yes. Do you have like a moment in your career so far where you were like you had like an epiphany, or you were like, oh, this is actually what I want to do, and now I know it, or you felt like, okay, this is significant what I'm doing right now?
The epiphany, I think, or at least when I started to connect all the little dots that I had, is something that happened to me more or less 3 years ago, when I was in the Isler archive, and of course I was doing a research that was focused on physical models, and it was something that somehow I always thought that my research is about physical models and how Isler worked in his engineering practice. So it was a historical reconstruction, but at the same time it was also relevant because basically the physical models that Isler developed back then are also the basis of contemporary form-finding tools, let's say. Or at least this is how I framed it. Then 3 years ago, when I was in the archive, all of a sudden I realized that one box of documents was much bigger than the others. It was something that this box had always stayed in this room of the archive. Mm-hmm. It was always accessible, let's say. It was not something that was brought in on a later moment. And this box caught some attention to me because I wonder why one of these boxes was much bigger than the other and what could have inside. I opened it, and the box was exactly the size of one of these big papers with the holes on the side that used to be the computer printouts, so the paper that was coming out of early computer calculations from the mainframe computers. And all of a sudden, my research that I was almost about to hand in the draft of my PhD started to take a completely different direction, because of course Heinz was not at all known for having used early computational approaches to control his structures, let's say. Mm-hmm. He was the guy that was using physical models, not computer calculations. Mm-hmm. And this discovery, somehow, this was a little moment, but changed, on the one hand, changed completely my research, because in that case I had to add one chapter to my doctoral thesis. Mm-hmm. And at the same time placed Isler in a completely new setting in the history of engineering, because he was not only the person with the physical models, but he was also one of the pioneers of computational approaches. Mm-hmm. And somehow this opened me also a new research or a new interest, let's say, in the way I was also conducting research and in the further development of my interest, let's say. Mm-hmm. So this transition from the use of physical models to the use of digital models is something that is very intriguing, mm-hmm. and is something I'm working on right now as a next research project. And this was really the turning point, but a very simple example, but this was something that really changed quite a lot.
Wow, it's also something that doesn't seem to be known much yet, right? Or is it like a new aspect of Isler that people don't really know about?
Exactly.
That you found in that moment in a way. That's quite something.
Exactly. This is something that I included also a bit in the book. And it was also interesting also to discuss with people that knew Isler, the lucky aspect of doing history with people that were active in the second half of the 20th century, that you can, maybe they are not alive anymore, but the people who collaborated with them or who were friends with them, most of them are still living, so you can interview them, you can adopt oral history approaches to reconstruct part of the picture, and they were also not at all aware about this aspect. So this was something.
Wow. Very cool. All right, that's it. That was my last question. Thank you very much for this interview. I enjoyed it a lot, and I recommend to anyone who's interested in this history of engineering to check out the book about Heinz Isler that was published not so long ago, right? How long ago was it?
It was 3 months ago, more or less, came out with GTA Verlag. Yeah. Yes. Thanks a lot, Leon, also for the nice discussion and for the invitation.